How's it going, everybody? This is Dr. Schulman, and we've made it all the way to the next part. So we did all the numbers and operations, and now we're into algebra. And I think algebra is very long, complex. We've been touching on it a ton, but algebra and linear algebra, or however you want to think about it, is basically just can we solve equations and expressions with variables? That's all really what we're gonna do. So I'm gonna show you a tons of ways. This one, the 4 algebra videos can be real long. I haven't really decided exactly how I want to make the quizzes yet, but after I look at all the problems, I think I'll be more set to do it. So this first video that we're looking at is expressions, equations, and formulas from context. So let me share my screen. Let's start there. Hopefully everybody can see it. So we have these things. So what is an expression? An expression. Expression is basically no equal sign. So that's like every time you're going to see the word simplify, you're working with expressions. And simplify really just means to make smaller. That's a lot of PEMDAS stuff like this. So that's what the expression is going to be. It's going to be like 5 squared minus 3 plus 2. So this is going to be 25 minus 5, which is 20. That's a very simple common expression. Now, when they say equation, okay, equations, this is basically we've got an equal sign. Now, when you have an expression, this is when you're going to be using your PEMDAS. Please excuse my dope ass swag, right? That's what we got here. Or Aunt Sally's if you have them. So that's parentheses, exponents, multiply, divide, adding, subtraction. But now once you have an equal sign, right? Let's say it's something simple like 5x minus 10 equals 30, right? Real simple. This is one we're going to use. I came up with this. It's just sad map. It happens most of the time because solving makes us sad. So usually we're going to subtract or add before we divide or multiply, before we do exponents and parentheses. Because look, the first step, it's not multiply. It's actually, we're adding 10 to both sides because it's the furthest thing from the x. So that's why 5x equals 40. And then we're going to divide the 5. It doesn't always work, but this works like 9 times out of 10 for students, and it really helps them out. So SADMAP totally helps. Now, we have equations, so that means there's an equal sign. And equations also have things like inequalities in them. And I'm going to do a little crash course of what all these symbols means first for your inequalities. So inequalities. So inequalities is not equal. So this is greater than, less than. Now, if you ever have greater than or less than, remember you should always have your x on the left because it points to where you want to go on the number line. That's 0. This is 5. Anything less than this is going to work. Now, every time we have one of these, it's an open circle. Also, it means we have dotted lines. So if there's an equation, let's say it's y equals, sorry, not equals, y is greater than 2x minus 3, right? Simple equation. So minus 3, boom, boom, boom. That's how we draw the line down 3. That's your y-intercept. That's your first point because my x is 0 over here. Then this is my rise over run, rise over run. And there's your y-intercept. Sorry, let me move over a little bit. This is my y-intercept, right? This is where you start. You start at the bottom. Now we're here. Start at the bottom. Now we're here. For your y-intercept, I'll write that neater. It's everywhere, every time you start. And this is your rise over run. So this number in front of the x is your m, or your slope. This means you rise up 2, run over 1, rise up 2, run over 1. Now, here we go. So this is a dotted line. Green is ugly. So here's our dotted line even better because we're not actually touching it. And because the y is greater, we're going to shade everything above. That's how you graph the inequality. Okay, but this is dotted. Now this is different if we have the equal sign. So if we have the equal sign, guess what? That circle is filled in. Its end equal to, we also hit it. So it will be a solid line as well. Hopefully that's useful for you. So let's say it's x is greater than or equal to -2. Here's our 0. Here's our -2. Close it, right? It's pointing to the right as long as your x on the left side and this side that's filled in. And let's say we have an equation. Y is less than or equal to, I don't know, 1/4 x. Why don't we do a -1/4 x plus 2? So I can change it up. There's my x. There's my y. There's my origin. These are your quadrants. They go around the Cartesian plane counterclockwise. Kind of fun, right? Because you have so many other numbers. We start at the bottom, which is +2. Then we're going to go down 1, 2, 3, 4. Sorry, down 1, back 1, 2, 3, 4. Up 1 over 4. So this is this line. Now this line we said was going to be solid. Oh, I missed it. This line is going to be solid. I guess I've lost internet for a second. So solid line, and because it's less than, okay, I see you. We're gonna be everything below it. So hopefully that's clear. Hopefully all this was clear as a nice way to start, as a little intro. All right, now we're synced. I don't know, my internet, I guess, is spotty. It's really hot today. So hopefully that was useful. Now, when they say context, it means word problems and situations. So that's pretty much what we have. Hopefully that was a good little intro for algebra. But we're gonna jump into it, do this a bunch of ways. These are gonna be long ones. Hopefully I don't scare you away. But if I do, guess flip, pause it, fast forward, do the ones you can't do, and come back to me. So I'm gonna go to Delta. This is my internet's fine now. I'm gonna log in. And we're going to edit assignment. As you can see, I've only done algebra. So there's two groups. There's algebra 4A. I don't know why that's 2B. All right, I got to change that to 4B. Let me just edit that one real fast first. Boom. Cool. Complete edit. Nice. And let's jump right into 4A. And what do we have for these? These are a lot of skills, right? Tons. I'll probably take a break somewhere through the video, but this is all the algebra you're going to need, no matter what level you're going to be teaching it at. So let's jump into it. Let's see how these go. I'm going to go split screen. I'll probably do half of it before I run out of gas. So here we go. Words to expressions. Nice and easy. Ooh. Okay, so here's a piece that I think is really useful. Let me just go to my drive real fast. I want to teach you something else. So this might be a three-parter. I really want to show you something that I made for this bridge program that I think will be useful for us to start. Solving word problems. Here we go. Just some slides I made to help you. So for these, none of them are going to be too crazy, but you got to know what all these words mean. So might as well teach you a bunch of these words. I'm going to download this as a PDF so I can write on it for you guys. And we'll start there. So this might be a few videos to create it because there's so much here. So when they say product, The first thing we're going to think about for product is to multiply, okay? They say the product of two, that means to multiply. When they say half, we're literally going to divide by 2, which is literally going to, or multiply by 1/2. When they say difference, this means to subtract. When they say increase, that's add. When they say twice, that's times 2. And when they say less, this means subtract. Now, if they ever use the word then means after the fact. So if they say less than with a number, 3 less than 4 or something like that, so this is after the fact. After the fact subtraction. More is adding. If it's more than, it's after the fact adding. You'll see what I mean. Sum again is add. Length is we're putting together. The length is usually the horizontal component. There's some more here. Perimeter, we add up all the sides. I'm going to try a couple of these. Base is the bottom. So length could be, I guess we can go vertical with it actually, depending on what it says. And angle is 2 rays with a common endpoint. Which is, there's my ray. My ray is AB. And here's my other ray, AC. You put them together, you have an angle. The vertex is the top angle of a triangle, so that's the vertex. Whenever they say complementary, means adds up to 90, just so we get some words in there, because it's going to be in context. Supplementary means adds up to 180. I always remember that supplementary is later in the alphabet, it's more. Consecutive is like 1, 2, 3, one after the other. Odds are 1, 3, 5, 7, 9. Evens can be divided by 2, so they're 2, 4, 6, 8, 10. And an integer we did already. It's a whole number, positive or negative. All right, so let's do one. So I'm just gonna write, I'm not gonna solve them, but I'm just gonna write them out. Okay, so the product of 7 and a number, so that's 7 and x, increased by 3, so added by 3, is equal to twice the number. It says subtracted from 39, so it's 39 minus 2x. 7x plus 3. It's subtracted is equal to twice the number subtracted from. From is also an after the fact, so we're going to add 2x. Add 2x, that's 9x plus 3 equals 39. Minus 3 is 36. Divide by 9, x is 4. Ta-da! Cool. 5 less than, remember, less than's after the fact. So 5 less than twice a number, so 2x minus 5 is, and math is always equal to, 1/2 the difference. So it's the difference, so it's got to be here in the front. 1/2 of 3 times the number and 13. So that's how you would set that up. You distribute the 1/2 and work it out, but this is the equation. One number, x, is 9 more than twice another number. So 2y plus 9. If the sum of the numbers, so x plus y equals 129, what are both numbers? So to do this one, this is going to be a substitution. X already equals this, so I can replace it. So it's 2y plus 9 equals, 2y plus 9 plus y, because I'm replacing this whole thing with that, plus y equals 129. So what do we have? 3y plus 9 equals 129 minus the 9s on both sides. So 3y equals 120, divide by 3, y is 40. But they want both numbers. So if y is 40, we just have to subtract 129 from it. 129 minus 40, that's 9. X is 89. X is 89. Y is 40. Cool. Let's keep it going. Kara's golf score is one less than 3/4 Greg's golf score. The sum of their scores were 153. So I'm going to make Kara K. So Kara's golf score was or is one less than 3/4 Greg. So 3/4 Greg minus 1. The sum of their scores is 153. That's K plus G equals 153. I would take this, substitute for this, and solve. The lengths of a rectangle. So I draw the picture. The length of a rectangle is one more. So this is our length. And that's going to be our width. Our length of a rectangle. So you always start with what you don't know about. So you start with what they do not tell you about. So it says the length of a rectangle is one more than 4 times the width. So the width is x. The length is one more than 4 times the width. So ready? 4x plus 1. That's the length. And the perimeter is 62. So it's this one. You gotta check the perimeter. You gotta walk around the whole shape. So this is also x. This is 4x plus 1. So the problem is x plus 4x plus 1 plus x plus 4x plus 1 equals 62. 1, 2, 4 plus 2 equals 62. Minus the 2 to both sides. 10x equals 60. Divide by 10, guess what you get? X is 6. The other one is 24 plus 1, so it's 25 and 6. Ta-da! There's the dimensions. All right. I could do the trapezoid, but here's the trapezoid formula, just in case you want to know. It's h over 2 base 1 plus base 2. And this is what a Sorry, I just lost control. But I'm going to share my screen again. So if they say that the measure, I did the trapezoid form up here, but don't worry about it. We'll get to it. We'll get to geometry. So here we go. We have two angles. And they say they're complementary. So that means the two angles have to add up to 90 degrees. So there's my 90 degrees. One angle is 6 more than half the measure of the other angle. So one is your first angle. So it's the other angle. And this one is 6 more than half the other one. So 1/2 x plus 6. So it's 1/2 x plus 6 equals 90. Here's another situation. Cool. And let's just do one more, just for the fun. Isosceles triangle. There's your vertex. We'll do the other two. Why not? I'll always set them up. Measure of the vertex angle. This means these are equal, and these are also equal. The measure of the vertex angle in an isosceles triangle is 6 less than 4 times the measure of the base. So there's one base, there's two bases, and the one we don't know about the base, so that's what it is. The one they tell you about is the long one. So 6 less than 4 times the measure of the base. This is 4x minus 6. It's 6 less than 4 times the base. So it's going to be x plus 4x minus 6. Now, if we have a square, we know it has 4 right angles, so 90, 180, 270, 360. Go around a whole circle, it's also 360, which is cool. So a square and a circle actually have the same amount of interior degrees. Why is that useful? Or how does that work? You can think about if you're measuring something, right? If it's close, we use grids, right? Like your GPS uses grids, but if we go super far out to measure distances, we use orbits. But either way, 360, if I cut this in half, I have a triangle. So a triangle is 180. So we set it equal to 180. we're good to go. X, 6x minus 6 equals 180, plus 6 plus 6. 186 equals 6x, divide by 6, divide by 6. 18 divided by 6 is 3. 6 divided by 6 is 1. 31 degrees here. 31 degrees here. And 4 times 31. That's 4. That's 12. Then we got a minus 6 from that. So it's 118. And guess what happens? If we add all three up, we will get 180. Ta-da! Here's the last one. So, and I'll probably use some of these on your quiz or test because these are great problems. So the sum of 4 consecutive integers is 22. All right, so x plus 1, x plus 2, x plus 3. If we sum them all, we should get 22, 222. So that's x plus 1 plus x plus 2 plus x plus 3 is 222. 4x plus 4 equals 222. Minus 4 minus 4. 218 equals 4x. Divide by 4. 4 goes into 218 5 times. Did I mess up? Because 4 goes into 218. Oh, because it's not 4. It's 6. 1 plus 2 is 3, plus 3 is 6. So it's 222 minus 6. So it says integer, that's why I know it has to be a whole number. So 222 minus 6 is 216, not 218. 4 goes into 216 5 times. 4 goes into 16 4 times. So the first one's 54, 55, 56, and 57. If we add all of them up, guess what we'll get? 222. Hope that was useful. I hope that was a great introduction. You got to see some problems. Yeah, cool. So let's jump into delta. So now they're saying 4 is subtracted from a number. So that's x minus 4. Ta-da, let's do a couple more. A number is subtracted from 9. That's 9 minus x. Oh. Six minus a number. So this one is 6 minus x. See how, like, the wording and subtraction matters, okay? A number is decreased by 3. That's x minus 3. They all mean the same thing, but we're all seeing that they're written the other way. The square of a number. All right, so that's x raised to the second power. One more. The sum of a number and 5, x plus 5. So try these yourself. Have fun with it. Do a bunch of them. It'll get you much better at this. I'm actually going to make you do 5 of them. I usually never do that, but why not? All right, so the quotient of 3 and the square of a number. So quotient means to divide. So the quotient of 3 divided by x squared. Ta-da! Let's do one more. 8 minus the cube of a number. 8 minus x raised to the third power. And do as many of these as you want to get good at it. All right, so let's evaluate some expressions. So here's a simple one. Evaluate. We've got 9z squared minus 5z plus 10. This is a happy parabola. It's positive. It means we have 2 roots. They can be the same. They could be imaginary, but we know it should hit twice. But they just want to plug in the 3. They want to know when x is 3, how much is y? So 9 times 3 squared. I always use parentheses to do these. So this is 9 times 9, that's 81. Minus 15 plus 10. 15 and 10, that's just a minus 5. So we're just left with 81 minus 5. Final answer is 76. So 376. Don't be afraid to show students this with Desmos, right? Ta-da. Don't be afraid to use the Desmos on this for the students. 9x raised to the second power minus 5x plus 10. There it is. Oh, it actually has no row roots. And when we just want the point 376. And you will see that the point line's right on the graph. Here's the point 376. Ta-da! So don't be afraid to show the students that this crazy thing actually means something. It can represent something. And this is what it looks like. There's the quadratic function. We call them parabolas. All right, let's keep on trucking. Think we're on a roll here. Equivalent expressions. Okay. P plus P plus P plus P. We got 4 of them. We got 4 P's. I like it. Let's do another one just for fun. Which pair or equivalent? This is 4R plus S. Nope, because this is plus S. So 1's out. 4 times 8 is not 12. 4R plus 8S and 8S plus 4. There we go. And adding them would just be 18. You don't multiply them. These are good problems. Let's do one more for fun. I got a bunch of P's and 3 Q's. There it is. 4 P's, 3 Q's. Cool. All right, let's keep on trucking. Now we're doing with exponents. So 3 squared. Just have your students draw yourself a square. That's a 3 by 3. What's the area? 9. So 3 squared plus 3 times 10. So the first thing you want to do is, so just remember your PEMDAS, because this is an expression. There's no equal sign. So that's how we know we're using PEMDAS here. So it's 9, and then we have to multiply first before we add. So it's 9 plus 30, 39. Magic. Cool. Let's do one more just for fun. And just do them until like they start making sense for you. So 8 squared minus 10 over 3 squared. So we know I usually just do one side at a time. So that's 9. And this is 64 minus 10. This is 54 divided by 9, which is just 6. Ta-da! Cool. 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 Ooh, 2 ways to do it. I like it. All right. So here's a 3 property. So identify the property that justifies each one of these. So we have x plus 10. Identify each step asks about the answer below. Okay, so line 1 to line 2, all we did was switch them. This is the communicative property of addition. And line 3, we went x plus 10. And then we did 3x plus, oh, we just moved around. So this is the communicative property of multiplication. So communication just means you go one way, you go the other way. You go one way, you go the other way. Ta-da. All right, let's do one more for fun. All right, this one looks good. So from line 1 to line 2, this is, we changed the grouping. So that's associative property of multiplication. Line 2 to line 3. 4 times 3. We changed the order, right? So this is a communicative property of multiplication. And then 3 to 4. It's associative property of multiplication again. Weird. Weird problems. It was tough. One more just for fun. The first one is we distributed. And the second one we did BA, B times 9, AB, 9B. So we had AB, but then we did BA to AB, B9 to 9B. So then this is the communicative property of multiplication. So know your properties. You can practice those. They'll be good. All right. We get to do a simplification. So here we go. 10q minus 9, negative 8q minus 6. So this is a very typical problem that you're going to see. And a lot of people mess this up because they're just going to put the 9 here, right? They're going to put their 9 here and they're going to go like, woo, we got it. Distribute the 9. They don't realize that we have to distribute the minus 9. The minus 9 is what we got to distribute. So it's 10q, negative 9 times this. So this is a positive 72q, positive 72q. And then negative 9 and negative 6 is a positive 54. 10 and 72 is 82q plus 54. Boom. That's how we do it. Missed all the time. People will always forget this minus sign. You got to really push that it's not minus just the 9. It's minus everything after. The minus goes to everything after, so you might as well distribute with it. That's a really common mistake. Beautiful. They did it right. All right, let's keep on going. Oh, we get a harder one. Level 2. We got some decimals here. Cool. Let's get after it. So now I got a negative 0.7. Whoa, it's moving. It's moving. That was wild. Negative 5x minus 8. And then at the end, we got to add 0.5x. Okay, cool. So remember, the minus has to go to both. I'm just going to do right here 7 times 5, which is, that's the ugliest 5 I've ever seen. 35, but I got a decimal here, so it's 3.5, 2 negative, so it's a positive 3.5x. And it's going to be a 7 times an 8, which is a 54. Move the decimal in place. So we just pretend the decimal's not there. Since there's 1, we move it. So 2 minus makes a plus 5.4 plus 0.5x. So boom and boom. We're left. Always put yours first. So it's 4x plus 5.4. I wonder how hard the next one's going to be. 4x plus 5.4. What? Oh, because 7 times 8 is 56. Oh, get over yourself. I multiplied off by 1. Whatever, we'll do one more just for fun of it. Oh, and they made it even tougher. Cool. So here we go. 0.5, negative 3k plus 8. Needs more space. And then we got minus. So this whole thing is minus. This whole thing is minus. It's got to come with us. 0.4, negative 5k plus 3. Bring this with us. So what is half of 3? The first one's a plus 1.5k. This is a minus and a plus, so it's going to be a negative 4. What is half of 8? 4. That's the first half. Now I got to bring this with me. 2 minuses make a plus. So 4 times 5 is 20. Move the decimal in place, so it's 2k. And then negative 4. We're in a positive 3. Well, 3 times 4 is 12. Move it here, and I have a k here. They got to go together. So this is 1.2 is going to be a negative 5.2. I don't know how they can make this any harder, but we're about to find out in a second. There's no way that's wrong. Sweet. Cool. All right, so let's go to the third level. Oh, they got crazy. So now we got fractions. Negative 5/4 f minus 7/4 minus 4f. We're going to save this for the end. 1 times 5 is 5. 2 times 4 is 8. So it's a positive and a negative. So that's negative 5/8 f. 1 times 7 is 7. 2 times 4 is 8. We're minusing 4f. Now, we got to put these together, but this is out of eighths. So if I take this 4, it's over 1, but I want to make it out of 8. So I have to multiply by 8 on the bottom and multiply by 8 on top. So 8 times 4 is 38. So this is 38 oh, sorry, 32/8. So it's a negative 5/8 f minus 32/8 f minus 7/8. You keep the bottom now. Yeah, you add, in our case, we add the two negatives on top. So it's a negative 37/8 f minus 7/8. That was wild. What a crazy problem. Negative 37 divided by 8 f minus 7/8. And all of the fancy steps. I like it. See, they changed the 4 to the 32/8. Oh, they put them together. That probably would have make more sense, and they just lined them up. Oh, I did that too. I did that too. All right, let's keep on going. All right, so now we're combining like terms. All right, so you must drag them over. Okay, so we have a 1 and a 4. That makes 5. Cool. I've got a negative. Oh, wait, I have this one. I have a 5. Oh, I have to do it here. I have a 5 and a 5, which makes 10. I just did the numbers first. I usually do the letters first. Then I have a 6x and a 5x is just 6 minus 5 is 1x. And let me move my floaty head. Nice. We did it. And we can graph this. We can graph them all. All right, let's keep on going. So W, W, and W. So if we have something like this, I put the 1 there. So 1W minus 5W minus 2W. 1 minus 5 is negative 4 and negative 2. So it's negative 4W minus 2W. It's negative 6Ws. Ta-da! All right, and now we do one with decimals. So I have 1n, let's put the 1 there, plus 0.76n plus 0.37n. Okay, 7 plus 6 is 13, carry the 1. 7 and 3 is 10, plus 1 is 11. So that's 1.13n plus 1n. Oh, so we just put them together. What's 1 and 1.13? It's got to be 2.13n. I like the multiple choice. That's fun. Nice. All right, let's distribute the negative. So for this one, we just have to distribute the minus sign, which is, oh, and then we're gonna make it simpler. So, oh, they just want to write an equivalent expression. So they don't want us to simplify this. So it's just negative 6p minus, I would simplify this to just be, oh, because these are different letters, that's why. And then this minus here has to go to this, so it's a minus 4. Boom. Nice. Nice. Don't forget the 2 minuses make a plus. So ready, just for fun, positive 0.5k plus 8m plus 8.8. It changes them all. Nice. We're flying through these. All right, let's add some binomials. So binomial, when they use monomial, it means one term, like 2x. If they have, oh, here, let me just give you them all. If they have, let's start, I guess we're at the beginning. So a constant is like the number 3. Monomial is like 3x. Binomial is 2 terms, so it's like 3x minus 4. Trinomial is 3x plus 2y minus 4. And polynomial means we just got a bunch. So it could be like 4x squared minus 3x plus 2x minus 1. That's what that means. This is linear. This is a straight line. This one's quadratic. If it's to the 3rd power, it's cubic. The 4th power, quartic, like a quarter. To the 5th power, Sorry. All right. So 4x to the fifth is quintic. All right, 4x to the fifth is quintic. After that, they kind of ran out of names. I'm sure they are, but after this, you just start saying to the sixth power. But when they say monomial, when they say binomial, it just means it has two parts. So here we go, the sum. 9x minus 6, it says sum, negative 9x plus 4. 9 and negative 9 cancels, negative 6 and a positive 4. Our answer is just some big old, it's a minus 2 with a halo, apparently. Beautiful. All right, let's do using this one. We might as well use this area model. So 2 times 6g is going to be 12g, because we got to see every way to do this, right? So here's 12g. And 2 times what is 14.7. According to the area model, 2 times 6g plus 7 is 12g plus 14. Ta-da! So pretty. I love the models. All right, let's go harder. Level 2, step it up. -4 and -8. And -4 and -7 is a positive 28. Then for this one, I will just do 28 times 4. 4 times 8 is 32. 4 times 2 is 8, plus 3 is 11. We have one decimal. Let's bring it over. It's 11.2. Well, in our case, it's a negative 0.2 r. Negative 11.2 r plus 28. This should be the right answer. Let's see if there's a level 3 to scare us into doing one that's harder. Oh, no harder. Okay, well, we're flying through it. Let's do some distributive property. All right, so we just got to distribute. 4 times 4 is 16k. 4 times -7, positive negative is going to make a negative 28m. And then 4 and 10 is 40. I don't think you needed me to write that one out. I would factor here. I would factor this if I had this, right? 16k minus 28m plus 40. First thing I'm going to do is I'm going to divide them all by 4. This is the way that I would write the answer. 4k minus 7m plus 10. Oh, wait, I just went backwards. Ha 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 ha. But it definitely works. Either way you slice it. I like writing the factored forms. Beautiful, beautiful, beautiful. All right, let's do an exponent. Now, so for exponent, there's tons of rules. If you want the full rules, I'm sure we'll get there when we look at exponents. I just have it here because I know we're doing a bunch of stuff. But if you want access to the set of rules, here it is. So if you want access to the set of rules, I'm just going to put the link right here. This thing is great. So I made this thing. Let me just, I'll copy the link and I'll show you what it looks like. So I'll just put the link right here for you guys. So these are all your exponent rules. So if you're let me move my face. Anything to the 0 power is 1. If you're multiplying exponents, you're adding them together. If it has the same base. If you're raising it, it goes to both. If you're dividing them, we subtract. A negative exponent flips it over. And if you're raising it, it's multiplying. So what does that mean? So if I have a to the second times a to the third, we just add them. It's not a to the sixth. But if I have a to the second times a to the third, it becomes a to the sixth. If I have a to the 0 power, a to the 0 power is 1, it's one group. A to the -1 means you just flip it over, so it just becomes 1 over a. And if we do subtraction, a to the third over a squared Just means you have three A's on top, two A's on the bottom. What is 3 minus 2? You're just left with an A. So here's a bunch of stuff to help you. It's got practice ones. If you want to do them, you can. So little pause, teach some more stuff. So we just have to do this. So this is use multiplication. So this is like there's ones here. So for this one, it's x to the first, y to the first, z to the first, but it's being raised to the fifth. So it's going to go to both. 1 times 5 is 5, times 5 is 5. So it's x to the fifth, y to the fifth, z to the fifth. X to the fifth times y to the fifth, oops, times z to the fifth. We did it. Oh, they wanted me to write them all out? What? X, 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 Y, 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 Z, 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 Z. Oh, they're annoying. All right, let's do a new one. Oh, now we have to condense. All right, so 1, 2, 3, 4, 5, X to the fifth. Then we have 1, 2, 3, 4, Z to the fourth. Ta-da. All right, let's do a new one anyway. We just did that one. Oh, no, we didn't. So this is A times C times C times C times C times C. 1, 2, 1, 2, 3, 4, 5. That's the way they'd like it. Doesn't matter.